So to look at that difference here, we definitely have some kind of purely sensory memory. And this is an important part in order for us to be able to create a continuous experience of the external world. It's important that we are able to remember what we just saw or what we just felt a moment ago. Otherwise, we wouldn't have this continuation. The problem here is that if we didn't have that kind of sensory memory, very, very short term, I mean, it's less than 0.3 seconds, so it's 300 milliseconds or something like that, we would have a huge problem whenever we are using our eyes, for instance. We know that when we look at objects, we move the eyes relatively rapidly. We make saccadic movements, which have a duration of about 100, 200 milliseconds. During those saccades, we're not able to see anything because the eyes move so quickly. So our visual information is really broken up by having these saccades. So if we sort of made a movement and then we had forgotten what we just saw a moment ago, we would sort of first see an image like this, and then when we have the saccade, the image is like this, and we would get completely confused. So instead, what our brain is doing is that it keeps a memory of what we just saw. Then it does a saccade, and instead of us experiencing sort of two different images, we experience a continuation which is created by our brain. It's not real because it's not what our eyes are actually seeing, but it's recreated as something which is real based on those two memories. And that goes for, in general, all of the sensory information that we receive. Most of it is coming in at different frequencies, and the frequency of processing is usually around 20, 30 hertz or something like that, which means that also in the visual images that we have by itself, we're not sort of seeing a continuous image input. We're seeing images going at maybe 20, 30 hertz, something like that. Similar in many ways to what you would see in a television, which is usually going at above 50 hertz or something like that. The point of that is that if it goes down at lower frequencies, we would start seeing it as separate images instead of seeing it as a continuous film. So this is part of the trick which is built into this sensory memory that we have in order to create this continuous experience of the external world. Now, the short-term memory and the duration of that is a little bit different in different estimates, but here it says less than 15 seconds. Some would say less than 15 minutes. Others would say less than an hour or so. So it's kind of expandable sensory memory storage, which I'm not really sure that anybody would really put a definite duration on. Basically, the short-term memory is in many ways equivalent to the working memory that we have in order to be able to also have an ability to have this continuous experience of us being the persons that we are and coming into a room and remember how we got into the room and keeping in an immediate accessible memory storage information that we can use here and now without having to recall it from a long-term memory storage. So all of that information is sort of floating around and creating the experience that we have of being conscious and being present in the environment that we are in right now. This is limited memory storage. So the ability to store items in the short-term memory storage is probably around, in most subjects, 7 units or something like that. Which means that you can sort of store 7 digits, or you can store 7 different items in your short-term memory storage. So if you really rehearse as much as you can keep those 7 images. If you want to store more, you will need to put some of it into a long-term memory, which takes a longer time and a longer processing time. What is also important for the short-term memory is that it's highly subjectable to interference, which means that during this time, before you store it in a long-term memory buffer, you are really prone to lose that memory again if there is something else which interferes with it. So basically, if you want to remember a phone number and you really try to rehearse that phone number to keep it, and then someone gives you another series of digits, another phone number to remember, chances are that you will forget the first phone number and only remember the second phone number, etc. So this is really the risk of the short-term memory, that it's so highly prone to interference with other types of learning, other similar information which can screw up what you just tried to remember. So eventually, in order to be able to recall later on, several days later or several months, several years later, the short-term memory storage here has to be transferred into a long-term memory storage. We know quite a lot about what anatomical structures are responsible for this and how that process is being done. We know quite a lot less about exactly how the long-term memory is being stored and in what areas, and especially how it is being retrieved again, what processes are involved when we want to recall something which has been stored in the long-term memory. So we basically know quite a lot about the transferring here from short-term to long-term memory, but very little about how it gets back into consciousness so that we can use it. And this is actually in many ways the most important part. Well, it's probably equally important, but if you want to recall something, if you want to have a good memory, it's not all about just putting it into a memory storage. It's quite a lot about how to get it back out of that memory storage in an easy and reproducible way. That's the real challenge. So here is a test for you. We're going to see how many of these items you can remember a little bit later. So I'm going to do a lot of interference in between. So you're going to get just a few minutes now to try to memorize as many of these objects as possible. And then in a couple of minutes, we're going to see how many of these objects you can actually remember. So that's your working memory or your short-term memory. And you're not supposed to write anything down.